Okay, welcome back to another, I guess, PlayBASIC Live revision about this MATH64 thing. Just quickly, so I just published the 10th revision of the library. Main changes are the lexing is updated, got some more display things for it as well, so you can sort of see what's going on better, as in the screenshot in here. Have a quick bit of a look at it. I'll run the example in a minute, but this is a screenshot of it. So we've got things like our declarations are the same, but now we can have single line remarks inserted inside them, which is something that PB can't do. Like, for example, we've got one down there as well. We can have multi-line remarks in the output, plus we can have white space. So that's more to do with the lexing ability of the library than the scripting language itself. Hopefully it was covered well enough last time, we don't have to rehash that again. What I want to do is I want to split the lexing away from the scripting language and have a lexing library for doing this kind of job. It might seem silly, I guess, to some people, but if you want logic in your games, this kind of stuff, you actually need tools like this built into the language. You can't get away with it. Eventually you have to write something that understands a bit of text, and without Alexa that's kind of pretty frustrating. Okay, I can see a way that you could actually expand lexing to do things like this square bracket stuff here. For example, you could have your own markup approach and then use that for display purposes or settings or whatever you wanted to. But to have a library that can just pass it a bit of text and get back the important bits of information that you need from it pretty easily, and then still be able to manipulate that data is handy. One of the reasons why I don't like some of those implementations is that you end up with a binary text format. But here, so our library we have a new ExitSCRIPT function. This is the particle code from our demonstration. Now I'll fire up PB. It should be the code that's in version 10 on the forum. So our particle library is still part of this example. The main library is this GUI driven thing here. So I'll hit run, hit F5. It's showing us that it loaded the particle script and it's lexed it at least. If we go to run, we can check out the variable stage. And because it has been compiled already, because we've got variables here, we can look at the view to view the code. I'm using the scroll wheel to move up and down. The display bit of here is using, it's just dumping out this as text. So MATH64 has a library that helps you with disassembling what the code is, and also has a syntax highlight library as well, which is what we're seeing here. Now it's not very good, but it just does very basic sort of representation of what your code was. Very handy again if you need to display something to a user, that kind of stuff. I mean, at the moment the palette's kind of fixed, but you can have an external palette, for example, and set the font different or whatever you wanted to. But I haven't bothered, you know. I do think if you're going to be making edit tools in PB for your own projects down the road, this kind of stuff is really beneficial, because you can give this to your, rather than you building the levels yourself, you can run through and build up your game's list of character types, and then give them a simple way of defining how these character types work in text, and they can see it visually to make sure that your game has phrased this stuff the way that they think it does. Yeah, or you can go all the way and do pre-processing of code, etc. You know, it's quite a big sort of scope. But so the Alexa now supports comments. They can be nested inside themselves, which PB doesn't support very well either. We've got white space returning back into it here. So this example here does run. We're capturing again. So this is the standard bit of code running the brute force test in PB. If I hold the mouse button down, we get a bit of a win back straight away. Space to exit out of that back to the GUI. You can load different scripts. Let's try this expression example, go to run. This one hasn't been compiled, it was loaded but not compiled, so we hit compile. And there's a little error flag now that will show you down the bottom if something didn't phrase. We'll view the actual code that was generated. A bunch of move statements pretty much, got some comparisons, some moves, a few function calls. Compiles and runs. So I go back to load script. The vector example, back to here, let's compile it. See our vector table, a variable table on the side here, and our code representation of it, our input code I should say, and then we could go look at the actual output code. This has more optimizations being applied to it, so we can shortcut most of these operations now. Saves dead operations being inserted into the output code. There are still some things here that you probably shouldn't be allowing to get to output, but for a little scripting purposes, it's not too bad. Now, of course, what I would be hoping to do is import, not just have expressions like these run, but have, you know, a kind of simple looping construct, maybe a go-to or something like that as well. So you can sort of branch around your script and have, we need to support labels inside here. So you can have a big blob of this code, have different labels for being different sections, so the code can be passed some initial settings from you into variables and make a determination about what you want it to do. And then branches off and does the thing it needs to do and branches back, you know, without you having to split up this code into blocks of separate code, make those choices in PB, and then call the appropriate script at the appropriate time. Yeah, it's just too much work for people. Yeah, so we are getting somewhere with it. We're taking our time with it pretty much. I've got a lot of, well, the last couple of weeks I've had pretty much, you know, no days off at all. So today I've got another half an hour left of my afternoon off. So I'm only having 3 hours off today, which is kind of sucks. So this will probably do us for a bit of a look at what we've got with this at the moment. What else is here? If example, let's go to run. So we have these if else or if end if supported, but we can't nest these infinitely. We can't support an else if, even though the token's implemented. We need internal label support for that. When the phraser sees certain bits of structural code, like an if statement or a loop or whatever, it generates, at the end of that block, it generates a couple of labels that are things like the exit point, the continue point, which is how exits and continues work. And these are predicted inside, when you're inside the loop block, for example. If you're inside such like an if statement like here, let's pretend this is a for next loop, you know, for just the sake of example. If we have a comparison here, we've reached a particular bit of code and we want to break out of the for next loop, and we would just call exit or exit for in PB. Both will work. What PB has to do, because when it says the exit statement, it doesn't know where it's going to jump out to. This address here is unknown. It doesn't know that until it's compiled the rest of the code following this exit statement. So what it does is it inserts a bit of code that says exit and then at this particular label, and that label will be undefined. So what actually happens is later on, when the label is defined in the future, at the very end of the compiler, it comes back and goes, okay, were there any labels that were undefined during compilation, and then runs back through and inserts their values into them. Which is what the third pass is all about. It's about patching up these addresses. They probably should be relative addresses, really, rather than absolutes, but it makes no difference in the end of the day. Absolutes is kind of more convenient for the runtime, but a relative address is kind of handy for things like if you wanted to compile a bit of bytecode and then save it out somewhere, like a function, for example, but you didn't want to keep recompiling this every time you dragged it into your new project. If you have your function kit, like maybe you've got 10 functions you always import into every project, having them pre-compiled and inserted directly into the bytecode at whatever location you wanted would be really powerful. We can't do that in PB the way it stands. It'd be nice, but we can't. All right, so that's enough about this. You'll find this on the forums. Revision 10 is down here. I'm not logged in, so I can't download it for you. A bit of a tidbit about, we've got a new function there or a new command really, called ExitSCRIPT, and it expects a parameter after it. So if you look at the usage down here somewhere, ExitSCRIPT 2, when we go back to PB, for example, we'll just look at the maintenance code that controls that particle loop. All right, so we're calling execute to run your script, which is our logic we've shoveled off onto this different process. It now returns a status. It's integer value, it's not a floating point. And this, so whatever value you pass out will be converted to an integer, so just be aware of that. And here I'm using that as a way of understanding what the condition was when this script ended. Did I end early? Did I end late? That kind of stuff. If status was 0, then it made it all the way through the script and didn't exit at all. If it wasn't, then something happened. In this case, a particle left the screen. And the only other situation that we can handle or pay any attention to pretty much is if the particle left the screen and shouldn't be drawn, is it going to come back to the screen? So if it's left it's firing up to the top of the screen bounds up here somewhere, leaves the frame buffer, then we're expecting it to come back into view at some point. So there are two of these return statuses down here. This logic here is handling that. So we're comparing, is the particle within the legal X range of pixels? If it is, okay, cool. We're checking then if it isn't above the top of the screen. If it is, we return, and we immediately, at this point here, then we go, if you're above the screen, return an exit code of 2, which means it won't be deleted. It'll keep processing this particle until it comes back into screen or it leaves the screen bounds of some other way. Yeah, that's a mouthful, isn't it? Yeah, sorry about that. It seems part and parcel for these library kind of extensions. They're hard for people to follow, hard for me to explain to people. But, you know, unfortunately, to make this thing more powerful, you have to get more complicated. It's just the way it is, you know. Anyway, that'll do for us today. Of course, it's back over here on the forums, down at the bottom of the forum here. Grab the current version. Look back up here if you want to look at the function, the public functions that are available for you to use with scripts. So there's a script that loads, makes a new script, for example. It expects you've loaded the script in from somewhere else. So you've loaded the bit of text in from a file or from grabbed it from your internal bit of PB code. Once we've had the new script created with the code inside it, we just call compile. If status returns okay, then we execute it. And that is it. Now that's all well and good, but to interact with the script, we've got to be able to pull these things like the variable names from, and these two functions here let you query a particular name and index from the variable, from the internal script here. Get the number of variables that were found, get the file name if there was any file name for it loaded, get the code out, get the script name. There are more functions than that. I mean, to have a look at them in particular, go to MATH64 and just, well, if you look down here, you can see there's a whole plethora of them. The ones here you want to be using are the ones, we've got script error can be returned, file name, variable name, flags, variable pointer. There's some copy functions here for copying between, copy from variable flight 32, copy from variable flight 64, etc. So you can get a pointer to an internal variable inside the script once it's been compiled at least, and then tell it to copy between two variables, or copy from a 64-bit variable into a 32-bit variable. Because internally PB is all 32-bit. So this is more of, if you want higher precision and vector operations pretty much. But there's a lot in here to dissect. There's a lot in here for you to actually pick through and wrap your head around. And it's a big leap of faith pretty much, isn't it? So that's how it goes. All right, I will leave it there this time. You know, grab the example, have a look at it, mess around with this stuff. You'll find all kinds of weird stuff in this example all by itself. And like the menu system here, it's probably weird to some people. We're using, we'll have a look at the example up here somewhere. Where does it create the menus? There it is there. So the menu system does a bit of lexing by itself. We have a bunch of these options defined in text. This is the menu option. This is the instruction about the menu option here. We have an on-click instruction and then a property of on-click. So when you hover over this thing and you click on it, we call load script menu function. It means our inner loop for processing the menu doesn't have to change when we add new menu options. That's it there. So we ask the menu, hey, what was clicked? And it goes, this action here occurred. And we check, well here I'm checking to see if it's a certain kind of function. Because I've inserted GY into these functions here. If something else generated an action, it might be an exit or a quit. So we just quit the application. But this part here doesn't need to update. I can add more functions up here and tie them up to other things just by adding the text. As long as this function here exists, we are golden. But that in itself is a different way of doing menus for people, you know. All right, we are over and out. Thanks for listening. Dive into this stuff, have a bit of a go at it. See what you come up with. I mean, who knows what you'll be able to make. And who knows what you'll find that's broken. So if you do find stuff that's broken, put it in the blog, please. I mean, you know, just make a post down here somewhere. Say, look, I was testing this stuff here, something weird happened. Is it me or is it broken? Probably it was broken. Yeah, that's how things go. Okay, until next time, I'll see you next time and enjoy yourself. Bye.